Hi everyone, today we would be looking at availability. As in the previous video, we have already talked about latency and throughput. It's very important for us to understand about availability. Not only availability, we will also be looking at redundancy, SLA, the service level agreement, SLO, service level objective, these four topics. So let's start with availability. What is it? Why is it important? And how important it becomes for a system to be available most of the time. So availability, this refers to the operational performance and availability of a system to uh, to be accessed and used when required. So you can imagine it through an example. Let's consider an airport. Let's consider an airport, and if it runways, terminals and services are operational and available to serve passengers and flight 99% time of years. 99%. Then the airport's availability is 99%. So from this we can say that out of 365 days, the available days the airport is there for the passengers is 361.65. So this is the amount of days it is available for the customers and like all the stuff. So the availability of that airport is 99%. So similarly, we having a system design. The odds of a particular server being up and running at any point. We have always taken an example of client server. So let's take another example. So this is a client and this is a server. Now this particular server, the odds of this particular server being up and running at any point usually is measured in percentage. So a server that is 99% available will be operational of 99% of time. Just like that airport, if this is available for 99.9%, let's say. So if that is the case, then this server is only not available for 87 hours the whole year. So 87 hours is something like 3 days. So you can say sort of that this particular server is available to us 360.3 days for a whole year. So that's a pretty good latency, availability. So now we need high availability. This is used to describe systems that have particularly high levels of availability, typically 5 nines or more. So now you must be thinking, what is these 5 nines, 6 nines and 8 nines? So I will just show you. Let's move here and let's take another color. So let's talk about nines. So nines. So it typically refers to percentage of uptime. For example, there are 5 nines means an uptime of 99.999% of the time. Let's talk about examples. So let's say we have 99%. So if we have 99%, it refers to not availability of 1%. That is, it is 7.7 hours of not availability. Similarly, 99.9%, it refers to 8.8 hours of not availability, because this is not available for only 0.0 like 0.1. Yes, 0.1%. So 0.1% of 365 days is 8.8 hours. So you can say sort of that if we have a system that has an availability of 99.9%, it is available to us for more than 364 days. And let's say you have a system with availability of 99.99%. So this will give you a downtime of let's say 52 minutes. 52 minutes. Similarly, if you have 99.999%, it would give you a downtime of 5.3 minutes. 5.3 minutes. And suppose you have suppose you have more, let's say 99.9999%, it will give you a downtime of 31.56 seconds. So this is how you keep reducing. So this can be known as 6 nines. 6 nines. This can be known as 5 nines. And suppose you have 7 nines. 7 nines of availability, which is very high to achieve. You only have a downtime of 3.1 0.16 second. Only this much. Like for the whole year, your system is only down for 3.16 seconds. Rest the whole year, the system is there for you. So it depends how important your task is. Suppose you have built a system that communicates between the airport staff and the aeroplane staff. Now, for the communication between them, it's very important. So you would want a downtime of only 6 or 7 nines. Like you would want an availability of 6 nines or 7 nines, or let's say at max 5 nines, not below that. Because if you go here, you see 52 minutes. That is very bad for a system which has to be highly available, because lives are dependent on it. So this was it for the availability part. Let's move to redundancy. Let's talk about redundancy. I will take the change. Redundancy. Cool. So let's say in the duplication of critical components of a system, to increase its reliability, we use redundancy. We will take again take a real life example. So an airport have different runways. So if one runway is undergoing maintenance, let's say this one is undergoing maintenance and is blocked due to some, let's say, unavoidable circumstances, flights can still take off the land using other runways. Let's say 2 flights went from here and 2 went from here, but because this is blocked, these can also run from here. So total of 4 flights will go from here. So this ensures that the airport remains operational even when one of its critical component is out of service. This is redundancy, because the process of replicating part of a system is an effort to make it more reliable. So you can think we have to find redundancy in our systems. Let's say you have a system which has something like this. It goes from here, then here. Yes. So what is the most redundant part here? This is the most. Because suppose if this is down, your whole system will collapse, because you don't have any alternate for this. So what do we do in such cases? What do? We add one more. Let's say one more. So suppose if one of them is down, we will have another one. This typically can happen in a case of load balancer, because load balancer is there for maintaining your load. But suppose what happens if the load balancer only goes down? At that case, you need to have a backup load balancer in the service. So yes, this was the redundancy part. So we will take example of the redundancy at the end. For now, let's talk about SLA. So this is a formal, written agreement between two parties. Let's say X and Y. So two parties, detailing the nature, quality, reliability, and scope of the service that has to be provided by X to Y. So we will again take an example of airport. So an airline might have suppose this is the airline. Let's say Go Air, and this is the ND Airport. Now, an airline might have this SLA between the airport with the airport. So this SLA might state that the airport must provide parking gates for the airlines 99.9% of time. So when they sign this, so they promise them, the Go Air, okay, 99.9% of time the parking gates would be available for you. If the airport fails to meet this agreement, there might be penalties or compensation defined in the SLA that the airport must pay to the airline. Now suppose one day Go Air comes and says that, okay, after the end of 1 year, you only provided us 99.1% of available. So for this 0.4%, you will have to pay us $1 million, because this was the agreement. This is how SLA works. Similarly, for services, let's say I'm using Google Cloud for my let's say personal website. We have a SLA between us that, okay, Google Cloud will provide me 99. So if the Google Cloud says that, okay, we will provide you 99.99% of the availability, during the whole year, but at the end they are not able to provide me, and I say, okay, you have provided me 99.7% only and not 99.9%, then Google Cloud would have to compensate me with, say, 1 year of free credits, or let's say some money for the loss that I have made. And this is what SLA typically looks like. So SLA is a collection of guarantees given to a customer by a service provider, and SLAs typically make guarantees on a system's availability that are made up of multiple SLOs. So you must be thinking, what is SLOs? So I will take the example. Cool. Let's come here and let's say SLOs. What is SLOs? So SLO stand for service level objective. These are specific measurable characteristics related to SLA, such as performance metrics, reliability targets, or other defined attributes. Let's take one more real life example of airline and airport. So this is the airline and this is the airport. So an SLO within the SLA might state that the airline's plane should not have to wait more than 10 minutes. The airline plane, and this is the airport, would not have to wait more than 10 minutes 95% of time. Less than 10 minutes 99% of time. This is the service level objective within SLO. So this gives a specific measurable target related to the broader promise of providing parking gates. So it is a guarantee given to a customer by a service provider. So it typically makes guarantee on a system's availability that whole constitutes of a SLA. So inside SLAs, so inside these SLAs, you can have several SLOs. Let's say you have one SLO for parking, you have one SLO for flying, you have one SLO for cleaning, you have one SLO for, let's say, performance. So this is a typical example of the relationship between them. This was taken on the example of airline and airport. But obviously, when it comes to real world, you have Google Cloud as a service provider and you as the customer, and there are several service level objective inside the service level agreement. Yes, so this was it from my side. When it comes to availability, we have talked about redundancy, then we have talked about SLA and SLO. Thank you for watching the video. Thank you and have a nice day.